Well, hi, good morning. Thanks so much for coming and joining me here in my shop on August 19th. Another beautiful sunny day. They just keep coming. A little threat of rain this afternoon, but same thing yesterday, but it didn't rain. It was sunny all day. Just beautiful. And here I am in my shop. So again, I don't want to spend hours down here today. So I think I'm going to go after these two gaudy capacitors here, and probably this one here. So some of the circuitry in this area of the radio is for a high voltage supply. These capacitors may or may not be involved in that. This one almost certainly is. It's right on the plug that goes out to the speakers. Lots of high voltage stuff going on in there. These look suspiciously like replaced capacitors. So why don't we take a look at this one, see if we can figure out what it's doing just from looking at it here. So one end is here. The other end is connected here. This is a little terminal strip. From here it's connected to a wire. Kind of gets lost in the bundle here a little bit. I think this is it coming out. Through the chassis out to the tone control. So the tone control has the on-off switch on it also. So these are the two wires heading for the on-off function. This must be the tone control. So this must be these connections here. And this one wire, it's got to be a shielded wire going out to the tone control. Coming back to here, the shield there it is. The shield is pulled out here and it goes down to the chassis. Here. So this is a capacitor connected to a wire going out to the tone control. So this is, I imagine, this is the tone capacitor here. This guy wouldn't take much, well, I don't know, I have to look in the circuit. I was going to say it wouldn't have much voltage across it, but that's not necessarily true. So that's what this one's doing, tone control capacitor. The other end is connected to this white wire. Into one of the pins on this is the output tube here. This white wire goes back to the connection to the speaker. That's where this capacitor is sitting. Now what about this one? So this one goes to the chassis on one end. The other one's on this terminal with a red wire. This is 1, 2, 3, 4. This is pin number 4. I'm pretty sure this is the plate. Well, I don't know. We'll take a look at the schematic. And then we got this one, which is tied between the same red wire, same as this one here, and something else. Oh, and this one. It's like a chain of them here. But I don't think they're in a chain format. I think it's just kind of a weird way of looking at it. Okay, let's look at the schematic, see if we can find these guys. Okay, first one would be the tone control one. That should be the easiest to find. So here's the tone control right here. And you see it's a treble cut through this capacitor. So bass tones won't find this path. They'll continue on to the speaker. But if this resistance is reduced, higher frequencies will be grounded out this way. So treble cut tone control 0.05. Okay. Now the other one is connected to pin 4. Pin 4 here, and ultimately connected, well, so I think this is the one that's mounted right on the plug or jack or connector for the speaker, smaller one. The pink double capacitor Ooh, could be that. 0.1. Could be that one. Nope. Nope. Yep. It didn't show that other capacitor right on here. Because it already exists in the schematic up yonder, way up here. Even though it's mounted right on this. Those wires, these two wires make it right to that jack. There's one straight to it. And then the other one, yeah, straight to it. So you could easily locate this capacitor right on the jack, right on here. So this is the 0.005 C40. Now we got one more. Probably a 0.05. Looks the same as the other one. And it was also, well, it's got to be this one, a 0.1. Well, then where's this one? Other side of a 60,000 ohm resistor. So let's look for that. We'll follow this other pink capacitor, assuming it's this, and see if we can find a 60,000 ohm resistor. And, oh no, you know, it's connected on this wire. This wire goes all over the place. This resistor could be anywhere in that radio. Well, we can always cut the part out and look at the size on it and see if it says 0.1. That would do the trick. Where's the other one? Again, it could be, you know, they show them here like this, but they could be spread out in the radio. And but the other one's pink. No, that's not right. This one here is pink. This is pink, and this is pink. This one? How'd they get to be pink anyway? Probable replacements. Okay, I can't tell for sure. This is the only one I can think it can be. Okay, let's go back to the radio. Okay, well, why don't we start by cutting this one out and seeing what size it is. .05. A tiny chief. Tiny chief. 0.05, 600 volt, Cornell Dublier, USA, made in the United States. Looks like it's perfect. Sealed beautifully. So 0.05. Now is it possible this is the wrong size? And somebody put this in because it's just as good as a 0.1. What's the difference? So it's definitely pin 4. Let's just double check a few things here. 1, 2, 3. It's definitely 4 on the output tube. So if this is the wrong size, then the right size wouldn't it be the 0.1? Can I somehow magically spot that resistor? So there's a red wire just going. I mean, there's one right here. Who knows what that is? Oh my gosh. Yeah, I don't know. Up in here, I can't really see up in here right now. So decision would be replace it with what it is, or put in a 0.1. Well, if it's on pin 4, let's look at the schematic again, just so I get my story straight. If it's on pin 4, it's on the plate circuit, and it's got 250 volts on it. There'll be 250 volts coming across here onto this. I wanted to look at that to judge the size of or rating of capacitor I can put in. 0.1. And no other point. Well, how many 0.05s are there? There's one right there. C41.05. Well, that's this one up here. It's the one I'm already going after. So there's only one 0.05 in here, 3.1s. So that's what's happened. I think somebody decided to put a 0.05 here instead of a 0.1. Is there any other capacitor at all on this line anywhere? There isn't any other capacitor connected to that line. It's only one. That's got to be it. Okay, we'll stick a 0.1. Generally, going a little bigger doesn't hurt with capacitors. Generally, not always. The bigger ones, 0.05s and the 0.1s. You can go bigger with those most of the time. The tiny ones, the 0.0002 and that, you probably should stick to exactly the same size capacitor. Okay, good. Well, and then okay, that's good. Yeah. I'm muttering here because I need coffee. Okay, got one in, not soldered yet. Let's get this one out of here. .005, just like we saw on the schematic. And go after this one next. Okay, let's put these to the test here. See how they stand up. We'll start with the 0.005. This looks to be in great shape. This could even be a replaced capacitor. Okay, oh, a good view of the eye. Here we go. 50 volts. Right open. 150. Right open. And the rating on this, 600 volt capacitor. So we'll go to 250 here. Yeah, it's showing a tiny amount of leak at 250 volts pressure. Now this was under pressure, but so this one is the tone control capacitor. And was it 0.05? Sangamo. Well, these aren't the same manufacturer. Okay. This also appears to be in pretty good shape. $50 volts. Right open. 150. Right open. 250. Yeah. Nothing really wrong with this capacitor. Surprising, such an old radio, but these are probably replacement parts. Is there a chance the replacement parts are better than the originals? Well, it would have come 20 years later, 15, 20 years later, better manufacturing in that. How about the Cornell Doublier? 50 volts, right open, right open, 250. Yeah, these were all in good shape. Of course, I'm going to replace them with perfect capacitors. Were these causing any kind of problem in the operation of the radio? Boy, it's hard to believe that, really. It's really going to be these old wax ones that are probably the ones that are dragging it down, if capacitors are dragging it down. Okay, I'm going to install those two, solder them up, and I think we'll give the radio a test at that point. Okay, I think we're ready to go. I've got an outdoor antenna connected to the radio. The volume is up just a bit. Switch is on. Band, band, band. Oh, it's gone loose again. Gee, how do you ever make this stay tight? Broadcast. I'm just hearing a roar come up. That's my air conditioner coming on. Good. Here we go. Now this radio comes with two large bulbs. I don't know if I have any like that. It's a very large sockets there. Hot diggity dog. Sounds even worse, doesn't it? Just a steady hum now. Okay, let's see if we can get the radio to come through. Yep. Maybe the next thing to work on is this tuning situation. Scratchy, bumpy. Well, it's receiving something. Okay, let's go for shortwave. Checking around 9 megahertz. So it's receiving stuff. There's a big CME hitting the Earth today, hitting the Earth's atmosphere. Well, it's not even full power. 98. Well, we're at 98 volts. That should be enough. Okay, not the greatest result there at all. But hey, radio's working. That's a thumbs up. Stuff is happening when you tune it. That's a thumbs up. And I'm pretty sure if I touched the antenna, I didn't bother doing it, but I'm sure if I touched the antenna, you'd hear an effect coming out the speaker, and that's a thumbs up, sort of. Yeah, the hum is stronger than I would have expected at this point. But we'll just carry on, working our way through the remaining bad capacitors. Or tomorrow I may fiddle with this a little bit. Why is it like that? This should be just beautifully smooth. Not gonna clunk like that. Well, I'll have to look into that tomorrow. Okay, well thanks a lot for watching today. More capacitors and maybe the tuning dial tomorrow.